Hi, in this video I'll be covering the Schrodinger's cat paradox. So a small introduction before I get into the topic. The Schrodinger's cat was a thought experiment devised by the Austrian physicist Erwin Schrodinger in 1935. It presented a scenario where a cat may be simultaneously alive and dead in what is known as a state of quantum superposition. Such a situation arises when the event is linked to a random subatomic event that may or may not happen. This experiment is what led to the coinage of the term entanglement. So, the experiment consisted of placing a cat in a steel box along with a Geiger counter, a small amount of radioactive substance, and a small vial of poison. To avoid discrepancies, the steel box was shielded from the effects of quantum decoherence, a situation which arises when a system is not perfectly isolated, causing its coherence to decay over time, leading to unwanted measurements. This experimental setup is designed such that when the radioactive substance decays, the vial of poison is broken and the cat is killed due to the poison. However, there is an equal probability of the substance not decaying too, in which case the cat remains alive. Thus, as long as the system is not observed, the cat can be either dead or alive or both. We know that both isn't a possible scenario. So here, as we can see, there's a cat, there's a vial of poison, and we also have the radioactive substance. On detecting the radioactivity, we have the Geiger counter which breaks the vial. So here we see the experimental setup as described. The existing Copenhagen interpretation of quantum mechanics implies that after a while the cat is simultaneously alive and dead. Yet when one looks into the box, one sees the cat either alive or dead, not both alive and dead, obviously. This poses the question of when exactly quantum superposition ends and reality collapses into one possibility or the other. This was the intuition behind the Schrodinger's cat experiment. In simple equations, an atom of the substance will have the following wave equation, which we have learned in quantum mechanics. Similarly, the cat's wave equation can also be modeled from above using this equation. So this is the possibility of the cat being dead as well as being alive. What was the motivation of this experiment? As we saw, Erwin Schrodinger intended to showcase this experiment as an illustration of the issues he saw with the existing Copenhagen interpretation of quantum mechanics. According to the Copenhagen interpretation, the particles existed in all possible states until observed, at which point they collapsed into one set state. The fault Schrodinger saw was that it was impossible to scale up this interpretation to objects that are visible to the naked eye, since if this was true, the cat would simultaneously be dead and alive until observation, which to him was observed, and it's also flawed. Over the years, there have been many interpretations of quantum mechanics apart from the Copenhagen interpretation. Each of these interpretations have been linked or related in some way to the Schrodinger's cat paradox. Some of them are the many worlds interpretation. According to this interpretation, both alive and dead states exist even after the system with the cat is observed. But these states are decoherent from each other. That is, upon observation, the observer and the dead or alive cat can be split into the observer and the dead cat, as well as the observer and the alive cat, although both these states are decoherent. Next, we have the ensemble interpretation. According to this interpretation, superpositions are sub-ensembles of a largest statistical ensemble. The state vector wouldn't apply to one, but to the statistics of multiple similar cat experiments. Next, we come across the relational interpretation. According to this interpretation, the human observer, the cat, and the apparatus are all quantum systems governed by the same rules of waveform evolution. In other words, all of them can be considered observers, and each will have a different idea of the situation until the box is finally opened. Lastly, we come to the transactional interpretation. According to this interpretation, the apparatus emits an advanced wave backward in time, which, combined with the wave that the source emits forward in time, forms a standing wave. The waves are seen as physically real, and the apparatus is considered an observer. In the transactional interpretation, the collapse of the wave function is atemporal and occurs along the entire uh, transaction between the source and the apparatus. In this transactional interpretation, the cat is never in superposition. Rather, the cat is only in one state at any particular time, regardless of when the human experimenter looks into the box. The transactional interpretation resolves this quantum paradox. So now we have seen the four different interpretations of quantum mechanics, each of which is related to the Schrodinger's cat experiment. And in each of these interpretations, scientists have used the Schrodinger's cat paradox as a baseline to compare their respective interpretations. This was only to give an idea of how significant and groundbreaking the Schrodinger's cat paradox was. With this, we come to the end of this video. Hope you guys understood this topic quite well.